Welcome everybody, you're watching Mr. Fugu Data Science. Today we're dealing with three tables that I was sent as an example from a viewer who wanted to convert these into one JSON file and then flatten them back down. Let's get an idea of what we're dealing with today. Here's two of the three tables which are going to be linked by this entity ID. For example, if you're using this as a key, like a foreign key for example, or if you were doing a merge and you wanted to know what we were merging based on, which I'll show you as well. Here's the third table that we're dealing with, and if you pay attention to this entity ID, you'll see we have 5 rows of 1, 5 rows of 2, which we can link together. The file format that I was given as an example is this. For the first entry of our data, this is what we're dealing with. We have primary key, we have a property which have values of lists, all right? Then for these properties, pay attention because you're going to have for each one 5 independent rows with key value pairs. We got to figure out how we could kind of structure our data to look similar or emulate this. And then we have to flatten it back down afterwards to get the original formatting. Let's get started, y'all. Don't forget to hit me up on my socials here. All the code will be in the link in the description below, as well as my GitHub, which will be in the description and the comments section. Both. Here's the imports that we're going to use right here. Pretty simple, straight up layout. So you've already seen the tables that we're dealing with. You notice that this empty row right here will be represented by an empty string. I just wanted to let you know that. So sometimes when you're dealing with that, importing it into a database such as MySQL, you have to consider null values, which are different than if you had a NaN or an empty string or something like this. Please understand that. The original file format was structured exactly as this. This is what I was given. We could easily throw this in at the last step, which would be represented when you're in the database. It may show as one entry here, but it'll come up for each individual row as a representation. We need to figure out the outermost entry for our JSON file as entities, and we need to store this list containing our data. This list right here will contain the first entry, which will be 5 independent rows of data for the properties. For example, it will have one primary key for this particular entry. The second entry has 2 of these names, key value pairs. Let's scroll down and we'll see that it closes off this list. We're still entering in the first entry into our dictionary. Going into now our second portion of our dictionary, we noticed here that I told you the primary key here is different and has 2 values instead of 1 with the same key. It closes out the second entry, closes out the list of everything. So we'll go back here and you'll see this list, and then it'll close out on the last part here. This is what we're trying to get, but I did it a little bit different for structure, but it has the same functionality unless you decide to import into a different database that's taking the raw JSON file. Then it's going to look a little bit different, which could pose a problem I mentioned to the client. So with all that rigmarole, we see that that report name was that first outermost portion, and then we had this internal report which is now representing each row. When we see my data, it's going to represent as 4 rows because I separated it. You're going to see what's going on here. Here's our entities, and then here's our independent data, which will have our key value pairs stored in here. I decided to try and merge these data, doing an outer join based on the entity column for each table I'm merging on. As you would see here, this is the primary key that we're dealing with, and if you see this, it says name underscore Y, because this name here was a blank name and this was a blank name, and it used it to distinguish it between each of the tables we were dealing with. This is from the first table. This would be from the second table. Here's the problem. We could use these data completely from the merge to create a JSON file. 2 reasons why I did not do this. If you're using many tables to merge on, it starts getting extremely cumbersome and difficult to read. This is kind of useless right here. You could build a function to simplify this and have it work entirely on its own independently. I didn't do this for a few reasons. One, this structure is correct for our data representation, matching with the entities if we're doing queries later. But creating a function to deal with this starts getting a little complicated, and I wanted to figure out an easy solution because sometimes you want less code for readability, especially for refactoring. was create our primary keys here and storing our values as a list, similar to if you are doing a default dictionary. I iterated through this third table with the entities, the entity IDs, and then I converted it to a set because really we only have two of those, right? And that's what we're going to iterate through. And I did an apply function, which is allowing me to take the rows that I'm doing because I took the set number of this. So we're taking basically each one of the independent ID numbers and we're going to iterate over this row wise, convert it to a dictionary, and we're grouping everything based off of the entity ID. We're appending this to our feature that we created with primary keys and all the values of what we're storing from this. So when you do this right here, we need to pay attention to something, okay? So let me unblock this so we could see what we get. We get a nested value section, which is going to basically take care of each row. Here's the entity part, which is storing everything inside of it for each of our entries. That's what I'm dealing with here. Then I'm calling the properties and the primary keys, which we need to store our data. And we're iterating through our first table that we had using iter rows. So we're going row-wise through the data frame. We have the name column, the text label, and the text long that we need to take. Text label, and then this entry was empty. It had an empty string, so whoever created this decided not to utilize the formatting. But if you come down here, you'll see that it's here. They chose to neglect it because it was an empty string. I kept it. We first have this outermost portion that we're going to deal with, which is the entities, and we're storing all of the information within this in the empty list. If we look here, here's the entities where we're storing everything in that list, which is going to be each one of the independent rows, which is further nested dictionaries. We have a feature variable which is going to store within our entities primary keys and properties. We iterate through the first table using iter rows. So we're going row-wise, iterating through the table, and you know we have two looping variables. This row is what we're interested in. We're storing within features name, text label, and text long. If you noticed here, we have name and text label, but we don't have text long because this particular entry had an empty string, and whoever created this did not want to have it in their data. I did. And we'll go down again and you'll see here the second entry actually has it. We will store, just like you're using a default dictionary, within entities. We're going to append dictionaries for anything that is within the features. We're taking that table 3 that we did the group by before with the entity column, and we're using an apply function to convert everything into a dictionary and using records for orient. I took the items as tuples for our new, let me show you, here's for each one of our rows, and I'm taking our information from this as tuples where this is our row and this is all the information that's stored within it. And I'm taking that and storing the first value, which is this, for each one of the rows into our entities. But you're going to say, why is properties and primary keys empty and everything else looks okay, doesn't it? Well, not exactly. Let's investigate this and see why. We have our text long, text label, name. Now we see primary key, properties. We have these from the second entry, which is perfect. Let's scroll down. We have properties, which is stored in a list. Let's go after the fifth entry. Okay, this stored properly, stops at this list and starts a new list. So what's the problem? This information is supposed to be stored within this. So we're close, but we're not exactly there yet. We need to do some manipulation. If we convert this into a data frame, we're going to see this is what we actually end up with. We kind of have an issue, right? We're going to start with the same beginning steps. We're going to take our empty entities. We're still going to use features, but we're going to use this as an empty dictionary now. We're still going to iterate, take the same columns. We are using the entities and append all of the values of the list as dictionaries. This looks fine. We still use our apply function for the third table, but instead we're going to do something a little different with the group by for the second table. Why? Let's figure out what's going on with this table. So let's print it off and see what's going on. So let's look at what this is. And here's what we have. This is the second table that we're dealing with. This is all the data from the end from this file. What about the other one? This one right here was the longer one, storing all of the properties information that we had. So we need to create default dictionaries to store all of this because it allows us to take a list of values for our key value pairs. You're storing all of your values within a list, and it'll be a nested list. And this gives you the ability to create a data frame row-wise because it's sequentially storing your information. And that's a hack that you can use to try to deal with this. This little discrepancy will have slight variation for how the JSON file turns out later from what what we're given, and I will show you that. I iterate through this third table using items. I use our default dictionary to store our values within properties, and we have the tuples that we have for this particular table. These are the values that are going to be in the properties, which is the 5 rows that you saw in the beginning. We now throw that within the outermost portion of our dictionary of entities and append everything as dictionary. When you take this away, it changes the formatting and doesn't store your data like you would think it does. Let's look and see what would happen. Let me blank this out, show you these data now. Here's our data. Let's getting stored, and it looks correct. So we look at our entities. We see it's all stored within this list. We have the name, text label, department. Then we have this separate name. We got to figure out, what's going on with these. This is the second row. Then we have everything within properties, which is a nested list, which is going to store your first 5 rows here, then the 6 through 10, and it looks like we closed out everything well. But what happens if I neglect this? Let's see what happens. This is starting to look different. You see this default dictionary, and it says it's a list, and it stores all of our properties. Playing with this later kind of gives us some issues when we're doing queries for structuring. So let's go back, make sure we put that back in. That little negation actually has some consequences later. We iterate through the second table. I could have did a function to this, but you're going over different data because this portion changes. For our primary keys, remember, one entry has an ID, the other has an ID and some name or something else. So we're storing this as a list of values with a nested portion with inside of it. This is what we're creating here. This is what I'm talking about. This is with the second entry. This is with the first entry that we're creating. Let's see what happens. We create our data. Okay. Now what about that report name that we had? We could throw that in here now too, but where is it? Scroll down to the bottom, and there it is. This will be represented in all 4 rows that we print out in our data frame. I'll show you with and without it. So everything looks good. We have our 4 rows. This is for one table. This is for a second table. These are for the third table that we are going to parse. What happens if I left that in there? This right here for the update. Scroll back down, do this, and you'll see it's represented here. We could keep this. It's not a big deal. I'm going to negate it for now because really it's unnecessary for what we're doing currently. I decided to try to flatten these data to see what is really going on here, and there's a bit of an issue. We have 3 separate tables with different data. The only way to make this data match is taking the keys for each of them and do a default dictionary and append empty values so all the rows match correctly. That's the only way to properly deal with this in this particular fashion of trying to explode both of these from the data we're given. Instead, I worked table by table to deal with this, where I'm basically trying to reverse everything. Since we had 3 separate tables, the first one was the first 2 rows, the third row was the properties, and maybe the fourth row was the primary keys that you see here, which is the third table. So notice I stored this is 2 entries, which represents 2 separate rows. We see here, this is 2 separate rows and it looks different, but it's actually the same. It's stored within this list with 2 variables. That's what we have here. I created this function. It was unnecessary, but I did it anyway, just as an exercise to myself. In order to flatten a dictionary, you need to use pandas JSON normalize. We're taking this as JSON.load string, converting our data frame to JSON and orient towards records. And we chuck it out, and this is what our data look like flattened out. The second table we're dealing with is this primary keys here. So to see what this looks like when we play with it, this is actually the third table, labeled 2, but it's actually the third one, taking our information, which is fine. Everything works out. This is actually the second table, labeled the third table. Now, if you wanted to flatten this out so it looks proper, here's what it looks like here, using an explode on this nested column here. Because I used the dot name, since this entry is a nested portion within this column, you have to use the dot notation. If you're using a database, you cannot have this, and you need to do an underscore or camel case or something like that to account for this. If you're going to send this off into a MySQL, we can do this in a future video, but I wanted to show you how you can create a JSON file, convert it back, and then create the 3 original tables that we started with here. This is the 3 original tables. But as always, I'd like to say please like, share, and subscribe. And if you subscribe, turn on that notification bell. Feel free to help support the channel through memberships, super thanks, affiliate links, buy me a coffee, etc. Anything is appreciated, and thank you for everyone who's helps support me through comments, giving me ideas for videos, or encouragement over the last few years. Please understand, I really appreciate it. See you in the next video. Bye.
Hey kid, don't ever let them get inside your head.